Let's look at alternate forms of comparison. When we wrote the hockey player class, we wanted to be able to compare one hockey player to another. We said we could do that by writing implements comparable for hockey player at the top of the class. And then that requires us within the class to write the compare to method. In other words, implements comparable is just a promise to write a compare to method someplace inside the class that looks like this. And the override is there because we're overriding or adding to a compare to method. How do we compare? We just take the difference between the hockey player's points in the general case, and that's sufficient to determine that one hockey player is different from another. If for some reason their points are the same, we can then compare by last name instead and return the difference of their last names, and so on. The problem with compare to is that you're only allowed to put one compare to within a particular class. So in this case, our compare to assumes that the only way you're going to want to compare hockey players is by points. Unfortunately, the problem with that is that quite often you want to compare by some other technique. So we have to find a way of allowing other forms of comparison. If you look at how we called the compare to routine, Collections.sort is the thing that does the sorting, in this case for a list of hockey players. And Collections.sort knows that since the objects are marked as comparable, that it can find a compare to, and it can call that compare to compare one hockey player against another. When it calls the compare to, notice that in the hockey player class, it's this current hockey player against another hockey player that's given to it. Turns out that Collections.sort also takes a different parameter. You can add an alternate way of sorting by adding a second parameter onto Collections.sort. In order to do that, you first have to make a class that implements comparator or comparator for the particular type of thing that you're doing. So in this case, a comparator for hockey player. Implements comparator promises to write the compare function, and the compare function in this case takes two different hockey players, and its job is to go get the information from each hockey player and determine which one is bigger. In this case, the compare routine first looks at the last names for hockey players by extracting them from the hockey player objects, and then it does what compare to essentially does when we wrote it, is it uses the last name string compared to the other hockey player's last name in order to determine the difference. Now notice the major difference between a compare to and a compare function is the number of parameters. In compare to, there was one hockey player being compared against another. In a compare function, you're given two hockey players, you extract the information from each of them in order to do your comparison. Once you've got your alternate comparison class written, then you can turn around and use that in the driver by making a new one of those objects, in this case the comparer class, and then passing that comparer class along to the sort routine. That tells the sort routine that it should use the alternate form of comparison rather than the default. Note also that in Java it's fairly typical that you can't turn around and pass just a method to a class, which is really what we'd like to do in this case. So what we do is we encase that entire method, the compare method, inside a class. And so the class's only job is to be a container for the method. Once we've done that and made the new one, you can then sort using the alternate form of comparison, and then we can do something like print all the information out. The problem with these alternate comparers is that their only reason for existing is to work with two hockey players. So in essence what that means is that rather than being external to the hockey player class, it makes more sense that that alternate form of comparison should have been written inside the hockey player class. So what we can do is we can take this entire class and we can copy it into the hockey player class and put it, for instance, at the bottom of the file. So here's essentially that same class, which has now been moved inside of the hockey player class, and it appears before the last closing brace. That gets the object inside the class, but it would still mean that the main program would have to do the new. And to make our lives a little bit easier, what we've done is we've said, why don't we have the hockey player class make the new comparer object, and send it out via a getter so that someone who wants one of these comparators doesn't even have to call new themselves. When you do that, then the hockey player driver now just does a single line that looks like this, call the hockey player class, and ask for a get compare by goals comparator, and then use that to do the sort. The one other little trick we've played here is that in the comparator routine, in the get routine, what we've done is we put the word static, the keyword static, on the front of both the getter and the class. This just allows us in the driver program to use the name of the class in order to call the get compare by goal routines, because that function really belongs to the class and it's common between all of the hockey players. Now, the next thing is that if you take a look at this code that we've written, this code makes a new alternate comparer object, which is immediately right below it, and then uses that. The only reason we made this name was so that new would have a class to call. And in essence, we've duplicated the name and a bunch of information. And what we could do is it'd be nice if we could just shorten this to say return new comparator. So if we leave out the blue space, you get return new comparator for hockey player. And so there's a shortcut for writing all of this code, and the shortcut is to slim it down to doing something like this, where you say write your getter and then say return new comparator and write the compare function immediately. And notice what I've done in this case is I've written the compare function as a separate idea to compare based on goals for hockey players, which is something that quite often happens. The bottom line of this is that what you can do is you can take this form of a comparator and you can adapt it for whatever class you've got. If you've got a class of students, it's going to become comparator for students. You're going to have student A and student B, and then you're going to have essentially the same sort of code that you have within compare to, where the goal is to simply subtract values in order to determine which one of the items is bigger or smaller. Now, we would hope that most people who write classes would write alternate comparators within them directly. That doesn't always happen, and so the alternative, going back to what we started with, of writing a class all by its own, is also a good idea in the case where the class that you're trying to use hasn't provided an alternate form of comparison.